I was just reading about something wild, the principal ideal theorem, and I think I finally wrapped my head around it a little.
Oh, really, Peter? I always see those big mathy names and my brain just sort of shuts down. What is it even about?
Well, imagine this, Stewie. In a computer program, you have tons of instructions, right? A principal ideal is like one very specific, foundational instruction or a core piece of data.
Okay, so like the single master key for an entire building. It's the one thing that starts everything.
Exactly. It's the seed, the one element that can generate a whole set of related things. It's super important.
So if that's the principal ideal, what happens next?
That's where extending ideals comes in. It is like taking that master key and making a bunch of copies or even creating subkeys that are all derived from it.
I am following you. So you build new stuff, but it all connects back to that original core.
Right. You are basically expanding the scope or influence of that initial core instruction or data. You are creating a bigger system from that one root.
So then the theorem itself has to do with all these connections.
Yep. The principal ideal theorem describes the mappings induced by extending those ideals. It shows how the structure you build from the original core relates back to the larger system.
So it's like a map that shows how all those copies and subkeys you made connect back to the first master key, and how that system makes the whole building work.
Precisely, Stewie. It helps us understand the fundamental relationships between these core computational components and the more complex structures we derive from them in technology.
Wow, I never thought about it that way. I actually sort of get that.
See? It makes sense once you break it down.